All right, hello everybody, and this is the second video for lesson 2.2 for proportional relationships. Okay, and what we're going to do today is we're going to identify proportional relationships and the constant of proportionality. It sounds like a lot of big fancy words, but this is actually nothing too new and nothing that we haven't done before. Okay, so it's all going to be pretty familiar, we hope. Okay, so let's look at this first word problem. A scuba diver descends at a constant rate of 8 feet per minute. Okay, this is a proportional relationship, and we're going to show why it is. So if we have an XY input-output table, okay, so here would be my X, here would be my Y. Okay, so I have my input-output table. My X represents minutes, my Y represents the amount of feet that the scuba diver has descended. So after 1 minute, if he's going at a constant rate of 8 feet per minute, after 1 minute, that scuba diver has descended 8 feet. After 2 minutes, we're just going to add another 8. So the scuba diver has descended 16 feet. After 3 minutes, again, same thing. It's going to be 24. Okay. And then after 4 minutes, just add another 8, and you get 32. So this is what my XY table would look like, my input-output table would look like. Okay. The reason why this relationship is proportional is because he's moving at a constant rate. Okay, so because the scuba diver moves at a constant rate of 8 feet per minute, that means this relationship is proportional, and here's why. I can take my Y and divide it by my X and get the same answer every time. So 8 divided by 1 is 8. Okay, 16 divided by 2 is 8. If I were to look at this row, 24 divided by 3 is also 8. And lastly, 32 divided by 4 is 8. So because these are all using the same exact rule, they all share the same proportionality. Okay, and so what that means is that the constant of proportionality would be 8. That would be my constant of proportionality. Because what I'm doing is I'm taking X, I'm multiplying it by 8, by my constant of proportionality, to figure out what Y is. Okay, so because that holds true for every single one of these values, this is a proportional relationship. So let's look at another problem though. So again, input-output tables, right? I have my X, I have my Y, I have my input or my output, okay? It's considered a proportional relationship if the rule is consistent. Remember this rule that we looked at during our input-output tables. Y equals A times X, okay? We're going to use A right here as the constant of proportionality, okay? So if I were to look, I want to see what's happening with X, with my input, to figure out what my output is. And if I look, I'm multiplying by 3, okay? I am multiplying by 3 because 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. So 4 times 3 would be 12. Okay? And then what times 3 equals 15? Well, we know that that's 5. Okay? Because 5 times 3 equals 15. So when I look at this, if I wanted to actually write the rule of this, this would be Y equals, my output equals my constant of proportionality, A, which is times 3, so it's going to be 3 times my input. Okay, so this 3 right here, this would be my constant of proportionality, because that is when I'm multiplying each input to figure out what my output is. Okay, this would be a proportional relationship. Now, if I had, also in this table, if I had a 6 down here, and say in my 6 on my output we had 21, is 6 times 3 21? No, it's not. 6 times 3 is 18. And so if that 6 and 21 was here in this table, then this would not be a proportional relationship because we're not using the rule is not consistent. We're not just multiplying by 3 every single time. Okay? But we don't have to worry about that because that wasn't a part of this, and this is a proportional relationship. So we're good. Let's just erase that right here. Okay. So let's kind of move on one more time here. So again, I want to tell whether the relationship is proportional, and if so, I want to give the constant of proportionality. So it takes Lee 1 hour to drive 65 miles. Okay, let's make sure I label this. So this is going to be my hours, which is also known as my x. And then my y is going to be distance. Okay, and that's my y. So here's my input, here's my output. So 1 hour to drive 65 miles, 2 hours to drive 130 miles, 3 hours to drive 195 miles. So basically what I want to see is I want to tell whether this relationship is a proportional relationship. So what is happening with my input to get to my output? Well, it looks like 1 times 65 is 65. Is that going to hold true before? Well, let's look. Let's just check this. Let's do 130 divided by 2. And if we were to work that out, it is 65. Let's do it one more time. 195 divided by 3 is 65. So because I can divide all these by my input and get the exact same, I can divide each output by its input, I'll get the exact same answer of 65. What that is showing me is that my equation for this, my rule, would be y equals 65 times the input times x. 65 is my constant of proportionality. Okay. Constant of proportionality. Okay. Let's look at another one real quick, and then we'll be done. Okay. Same type of problem. I want to tell whether the relationship is a proportional relationship, and if so, we're going to give that constant of proportionality. So Sue types 45 words in 1 minute. So here we go. We have our time, and here we have our words. Again, x, y. So she types 45 words in 1 minute, types 60 words in 2 minutes, and 73 words in 3 minutes. We need to decide if this is a proportional relationship. Well, if I were to do 45 divided by 1, that's just 45. For my second row, though, if I were to do 60 divided by 3, that's 20. Notice how these are not the same. Okay? So because of that, this is not proportional. This is not a proportional relationship, and therefore, whoops, losing my pen here. Well, it's not proportional. Let's leave it at that. Not proportional, and therefore, there is no constant of proportionality. We don't have to even worry about that. Because it's not proportional, there's no constant of proportionality. Okay, just a quick recap. Let's go back here to the beginning. We want to remember, okay, constant of proportionality is y equals ax. It is this a in your rule. Okay, so that's going to be your constant of proportionality. And you only have a constant of proportionality if the rule holds consistent throughout the entire table. Okay, so for example, in this table right here, because I'm multiplying by 3 every single time, my constant of proportionality is 3. Okay. Also, what you could do, just another way to check to make sure that your relationship is proportional, is you can divide your output by your input. So divide your y by your x. So 130 divided by 2 equals 65. 195 divided by 3 equals 65. And if they equal the same thing every single time, then that answer right here would be your constant of proportionality. Okay? And I think after watching this video, you guys should do well on this next lesson. Okay? And good luck to you.